sample difference? Or sample standard deviation?
N equals the number of people, the size of the experiment, right?
Yeah, so it should be 22?
Yeah.
Okay.
Hmm?
And I mean
I
the
feel like
mean is like 11.9. I don't know if that's what it's asking.
the DF would be like the sample difference.
Yeah, but like every single one, like there's 22 sample differences.
Oh. The sample difference mean.
So that's 11.95.
Okay. So then an N would be greater.
And I mean, if we get it wrong, we have another chance, and so.
Yeah, we'll just. I mean, the good thing is it's only one of two, you know?
I think it's N2 though. That sounds right.
Yeah.
Not that I know what I'm doing, so I don't know if that's very comforting.
Okay, here's the t-test. The t, it has df on here.
Oh,
It
Ooh.
says df is 21, so we're still right.
okay. I'll fix that in my notes though, like if we need to go back to it.
Hmm
21. Alright, so
So t equals,
value.
um, well,
The p-value is
I'm gonna
0.
split my screen because this is getting like just really confusing for me.
So if the p-value is less than the level of significance, you reject the null. So it is less than because it's 100th instead of a 10th, or 1,000th instead of a 10th. So it's rejected.
Okay. Okay.
Okay, so number
So, which
oh,
one's the p-value on here? It's this.
p-value is the sig thing.
So that's 3.001.
Yeah, and then the level of significance is 0.01. So the p-value is less than the level of significance, so we reject the null.
Okay.
Okay, you decide to try another alternative hypothesis. This time you use that the mu is greater than 0 and you keep the same level of significance. Did the p-value increase or decrease? I don't know.
Mm, increase?
And why do you think that, though? Because I don't get it.
I don't know that I'm right though. Well,
No, wait. So it says on here 95 level of confidence. I don't know.
so doesn't that mean it's like the upper part or whatever? So that would increase or no?
Hold on. I think I have this part wrong because it says this is like the 95% level confidence interval of the difference.
Number, wait, hang on. Number 10. What was number 10? Did you guys get that?
0.001.
So it's gotta be increasing, right? Wait. Mm,
Okay. So is this going to be the 99th percentile confidence?
I think whatever it's defaulted to when you do it.
Well, because each
65.
one's different. So it said the level of significance on here though, right? What was that?
95, right? No?
Oh, 1.
Yes? Mm,
So, can I do this?
okay.
What?
Okay, so let me see if it changed anything. Did it change the p-value? Um, the only thing that changed was the lower and upper. And they
What
increased.
what did you get for lower and upper? Because I got negative 128.64. Is that sounding for lower? Is that right? Or am I way off?
I got negative 0.2621.
Okay, so I'm way off.
I don't know, you could be right and I could be the one wrong, though.
I think you're probably right.
I don't know, it's my
I'm
first time.
still trying to figure it out. Like, I don't think I'm doing it right in SPSS. I think it's the problem.
Let's just put increase and then we have a 50-50 chance we can just change it next time.
Yeah,
Yeah.
true.
And I put you would fail to reject it because it was rejecting it before because it was less than.
Then, okay,
So now if it was greater than, then you would fail to reject it,
okay.
I think. Okay. Based on your response to the previous question, what conclusion do you make? We have significant evidence that the difference between the two groups.
Well, there is a mean difference, right?
But isn't that like the P-score thing, and it's so small?
Wait, aren't the
Super small, yeah.
So
okay?
I'd say insignificant. Wait, I think it's insufficient evidence that there is a mean difference between the two groups. So I think it's the last one.
Okay, that's what I was eyeing, but I wasn't sure. And I don't understand 15.
Oh my gosh, I just like, oh, got a shot of pain up my spine. Ow. Which alternative hypothesis would give you the smallest p-value? I don't know.
Maybe not enough information, depends on the problem.
Ah! What did you say?
Maybe not enough information, depends on the problem.
Yeah. Well, I guess. Well, it's saying in general, so maybe this is like a general rule. I'm gonna try seeing if it anything on Google. Oh my gosh, I can't type today.
Glenn's making noise on there. Okay.
I think it might be the not enough information thing because if you think about it, like,
Well, because I mean, like even like a negative, like sometimes a negative number is like a bigger. I don't know.
I have p-values probability to the right of our test statistic calculated using null. Further out the test statistic is on the tail, the smaller the p-value. So it could be greater than or less than depending on what the hypothesis is, I think. So I think it's not enough and it depends on the problem.
What's the point estimate?
I don't know. Is that what the p-value is?
I don't know. Well, that's number 16.
It comes up with a whole bunch of different, like, I don't know if any of this is even right,
Well,
so
go to the 95% confidence interval. What does that say?
The 95
Yeah.
for what? The confidence interval?
Well, there's lower and higher.
The lower and upper?
Yeah, is it gonna be like the mean in between the two, like a point in between the two?
The mean mean is 11.9545, so 955.
Maybe that's what it is. I don't know. I'm gonna.
Let's just guess. Let's just go with it.
What is the point estimate? Single value given as the estimate of the parameter of a population.
Okay.
What does parameter mean again?
I don't